So the chosen application is playing rock, paper, scissors with AI. So the goal of this application is to make a way for the user to play rock, paper, scissors traditionally with his hand. So we will limit the use of the keyboard and the mouse. So since there is no defined strategy for winning this game, the AI is not a winning system here. Rather, we are making a visual recognition of a hand gesture. That is, we're using this sign for scissors, rock, and paper. So then, after recognizing the sign being used by the user, the program will make a random move and determine who is the winner. Proceeding to the code, so we are going to collect a 100 samples for each clause. We are defining a clause for rock, a clause for paper, a clause for scissor, and a clause for nothing. Nothing we need since we have to consider that when the user is not has not yet decided on his move, the model has to predict that it is nothing and not a hand gesture. So the number of samples being collected for each class is 100, and then we're going to use the function gather data, which is defined here. So what this function does is capture the image from the webcam and define a box of this size. So within this box, we are going to define the hand gesture. So what we are going to do in this step is collect data samples for each of the clause. Now we are going to run the code for the collection of the samples. So we are going to press S to collect the data sample for scissors. It is better to collect the data images at different angles. We press R for rock. And for nothing. Once the data collected, we are going to visualize the data. So let's run this. So we can see 8 random pictures of sample collected. We can run this again to have another 8 from the samples. Now we are going to preprocess the data and split it. Here we are going to have 400 labels since we have 4 classes and 100 samples for each. Now we are going to prepare our model for fine-tuning. So we are using the pre-trained model NASNet Mobile, but we are going to use it without the head. So this is because we only have to predict 4 classes, and this NASNet Mobile model is trained on 1000 image net. So we are also performing transfer learning, where we add a few necessary layers on top of a base model to create our custom head, in which the final layer will contain the number of nodes, that is in our case equal to the number of classes, that is 4. So here we are constructing the whole model. So we are going to run this, and we are going to see that the number of layers obtained is going to be 773 in our scenario. Step 5, we are going to train our model, but before we have to perform some data augmentation We are going to perform data augmentation along with transfer learning so that we don't have to worry about having only few samples for training, since we are only using 100 images for each class. So these are the augmentation that we are doing. So for example, for horizontal flip, we are setting it to false, but if we set it to true, the user can use both of his hands to perform a hand gesture. After doing this, we can compile the model using the Adam optimizer. And the main metrics that we will consider is the accuracy. Next, we will have an epoch of 15 and a batch size of 20. So an epoch is basically the term used in machine learning that indicates the number of passes of the entire training data the machine learning algorithm has finished. So now we are training the system and we have to wait for it to be over. So here is the result after training our system. We can see that with more iterations we are reducing the loss and gaining in accuracy. So we can perform more iterations to even reduce the loss more, but this result seems to be satisfactory enough. So let's see and check our accuracy and loss graph. So according to the graph, we can actually see that the accuracy is quite good. So we can proceed to the next step. So before we are going to save the model and load the model. Now we are going to test it on live webcam feed. So let's see the accuracy. So nothing, 99%, which is correct. Rock, 86%, 91%, so it's fairly good. Though we can see that the program has its certain lag, so 99% for Scissor. Let's see paper. So we can see that the program is a bit lagging, but the accuracy is pretty good. Now we are going to see the code for the final application. So we have a first function for determining the winner for each round. So for example, if the user move is rock and the computer move is paper, we return the computer as the winner. The next function is going to show the final winner for the full game. So if the user score is greater than the computer score, we are going to display an image to show that the user is the winner. Whereas if the user score is less than the computer score, then an image which shows that the computer has won is displayed. We are also going to allow the user to press enter to play the game again and else exit. So I have modified the code such that the score of the user and the computer score is also shown. Last function is going to display the computer's move. So we have to predict the computer's move. So after predicting, the image will be shown such that to be realistic and show like we are playing with a person, we have to see what the other user is playing. Now this is the final application. So the initial move for both the user and the computer will be nothing. And then the score will be 0 at the start for both users. So now we are going to define the threshold for the percentage of a prediction. So if we have a confidence threshold of 70%, we are going to take the prediction of a hand sign. as we will wait for the prediction to become greater than 70% to be able to predict a hand gesture. We will also be using 5 predictions instead of a single one. Then for each frame being captured, we are going to extract the region of the image within the rectangle we are considering for the hand gesture. Then we are going to predict the move and get the index of a predicted clause. The clause name of the predicted clause is then found, and we are going to get the confidence of a predicted clause. We make sure that the confidence is above 70%, and we add the move to the DQ list. So we are going to proceed when nothing is not true and hand inside is false. That is, the hand inside variable is helping us to not repeatedly predict during the loop. That is, if we keep our hand like this, we're going to keep on predicting rocks. So we have this variable hand inside such that we have to remove it from the box to predict the next move. So once the hand is inside, we set it to true and we get the computer's move. We are going to find out the winner between the user and the computer. We display the computer's move and subtract one atom from the total atoms. The final winner is decided if the total atoms become 0. If we want to play again, then this piece of code is executed, else we exit the program. This section are the annotations that will help the user know which move he is doing, and the computer's move and the current score for him and for the computer. He will also know the number of atoms left. And he will have a rectangular box where he will know where to put his hand sign, which will be predicted. So now let's run the final application. So we are going to predict the first round. So the prediction is correct, it is rock, and the computer's move is paper, so the score goes to the computer. And the number of attempts is now 4. So rock, paper, scissors. And now the next prediction, we will see that if it is correct. So scissors and paper, so the point is for me, which is correct. Now let's see if it can detect paper. So now it is a tie, so no one gets the point, and the prediction remains correct. When there's nothing in the box as well, we can see that the computer's prediction is correct. So as it was previously discussed, we have to remove our hand from the box to predict the next move. Now we are left with one more attempt and the score is still tied. So let's see the last prediction. So the point goes to the computer. And the computer wins. So we can press enter to play again, else we can exit. And I have edited the program such that my score and the computer score are displayed. Though I have to change the font and the font style to be able to see it properly. But we can see that the score is 1 for me and the computer score is 2, which are both correct. So we have been able to predict correctly all of our moves, and the computers has been able to predict and has been able to perform a random move. So we have successfully been able to run the rock paper scissors with AI application.